Thank you. Welcome back, everyone. I'm excited to be moderating this panel on driving dynamics, where code meets the road. Software now shapes the throttle response, torque vectoring, and the very feel of a car, from the motorway to the racetrack. The challenge is to push capability without losing authenticity and to launch reliably at scale. To explore that balance, I am joined today by Steiner, Executive Board Member for R&D at Porsche, Stefan Fischer, Head of Vehicle Energy, Motion and Body at CARIAD, Roger Atkins, Founder of Electric Vehicles Outlook, and former race driver Timo Bernhard. Please welcome the speakers onto stage.
Thank you.
Thank you. Thank you for joining.
Hi.
Great, thank you.
Hi, Kana.
Thanks for joining. Just a quick reminder again to our online audience, please keep the questions coming, and I'll try to weave them in towards the end of the sessions. So maybe let's start off with a very, very basic question. So how does software actually change the experience and feel of driving a car? I mean, people talk about how software will change everything, but can we actually keep that fun of driving that we have known during the mechanical era, and when we controlled actually, the driving experience?
Yeah, thank you for this question, and this is our business. So software and code does definitely improve dynamics and performance, but driving experience takes place in our head, in our body.
Right.
And if you do it right, if software and hardware, so mechatronical systems and software go hand in hand, the experience is well, and the car doesn't drive like a computer, but maybe like a 911 or a Taycan, like a typical Porsche. And this could be achieved with software in an even better way if you do it right.
Right. Maybe I'll have everyone answer this question, since it's a fundamental one.
I think it's not purely about keeping. I think it's about extending and even improving it. Because code meets the road also means what is the connection between the car and the road? It's the tire. And the input into the car is the driver. And everything in between, mechanical systems, mechatronic systems, sensors, actors, which is steered by software. So I think it's even more than keeping. It's a great opportunity to improve it and to make it even better.
Timo, from a driver's experience point of view, though, is it different?
Yes, exactly. I mean, when I started my career at the age of 10 years old, I did the purest form of motorsport, karting. You know, you have no driving aids, you have nothing, no software or very limited software. And then over the career, you get more and more involved in different cars, more technical involved. And this cumulated for my career, or in my career with the Porsche 919 hybrid program, the Le Mans winning and World Championship program. This was a purely high-tech car. And beginning of the project, I could never believe that this would feel like a proper race car. But in the end, because it was a hybrid car, 1,000 horsepower combined power, but in the end, it was the best car, the fastest car, the most advanced car I've ever driven. So this showed me that, with the human factor and, with good engineers and with technical, leadership, you could have a car which feels genuine, which feels good, which feels, honest in feedback, but you can be faster, quicker, less tire consumption, all in once if you have this technical progression. So the basic needs to be right, and on top of that, then you can have a better performance, with software or technical advances. Yeah.
Great. Roger?
Well, I think the thing in this journey to electrification is to turn everything on its head. A lot of people think electrification is boring, is quiet, is dull. So what I have learned in my life, although I'm not an engineer, engineers love a challenge. So the challenge is to use software, is to use the new electric vehicle platform, the proposition, to reinstate those driving dynamics, to find a way to give the character, the personality, the fun, into the drive of a vehicle, and if you like, counteract or prove wrong all the people that think we're shifting from something that was super exciting to something that's a little bit boring. That's not the case. The driving dynamics in a really powerful, well-engineered, beautifully crafted electric vehicle with torque vectoring and all the other incredible dynamics to the car can make it, well, a driver is always going to be, especially a race driver, is always going to know this better. But yeah, driving isn't just about functionality, and especially in brands like Porsche, it's got to be much more than that. It is about that whole driving dynamic and experience. And you want to feel like you're driving a character and a personality, not just a lump of metal. So that would be how I see it.
I mean, Roger, you talked about it through the electric vehicle lens, obviously, from your perspective. But Mikhail, I mean, it'd be interesting. We always talk about these software advances in the EV era, but I mean, how does it actually? I mean, can we have these software, benefits in the other ICE hybrids as well? And how does software fit in with Porsche's lineup of these combustion engine cars and hybrids?
So in principle, every kind of drivetrain will and could take benefit. And in terms of complexity, a hybrid system, as you have more sources of torque, is even more complex to manage than a battery electric vehicle. And the beauty about software that it computes faster than a human brain, that it can compute more data, then it can have access to more, let me say, sensors, actors, to info in the cloud, to crowd info, helps that the car could do things a human driver couldn't do. And once again, if you do it right, and this applies really to an ICE car, to a hybrid car, to fully electric car, you can enhance not only the functions and the performance, but really also the experience in a positive way, in a natural way, in a way that you love your car.
Stefan, I mean, Mikhail just said if you do it right. What are the challenges of embedding? I mean, is it harder then to embed these software benefits into an ICE and hybrid vehicle compared to EVs? What are the actual challenges of embedding these software technologies to make sure that it's rolled out in the right way?
I mean, as Roger said, engineers love challenges. So we have the great possibility to develop a software stack that can be used for all different kinds of powertrains. If it's an electric vehicle with electric torque, or if it's a combustion engine vehicle where we have to control and steer the combustion engine, which, yes, is a bit more complex, or if we say altogether in a hybrid car, as Timo described it with the 919 hybrid race car, in the end we have, as I said, an opportunity and a possibility to build one software stack where the different torque sources can be added into one stack so that we really have a scalable platform that in the end can really be successful and also very nice to drive for all the different vehicles. And as we also said, it's about emotions, it's about an experience that we also can add to comfort and safety. And all that is part of our software stack that we develop. So I can't really say, is it hard or is it maybe easier, but it's about a very nice technical challenge that we can solve with one software stack.
Right. I mean, both Roger and you just mentioned about this personality and the emotional connection to vehicles. I mean, Timo, you talked about your experience with the hybrid just in the initial remarks, but I mean, software-defined vehicle is still very new, but do you think you can still have that emotional attachment that drivers often feel to a car and that personality, that strong personality that each car holds in this new era?
Yes. I mean, yes, I'm sure about that, but I think the key is that it feels, the human factor, it needs to feel genuine, needs to feel honest. And the first time back in 2019 when I drove the first fully electric Porsche, the Porsche Taycan, first time I drove it, I was very particular about how does it steer, how does it brake, because I know brake-by-wire, you're recuperating. So first thought was, okay, you might take some feedback off, some feeling of the driver. But in the end, I was astonished, or positively, astonished that it was engineers did a great job. You do recuperate the energy, but you still have this feeling, okay, I have a brake pressure, I have a brake bite, and I can control it. And I think that's the key. So if you understand the basics, if you have this feeling for the driver, which feels genuine, and on top you have the, technical driving aids or, technical parts on top, I think then you improve your performance. So for me, this is, throughout my motorsport career, that's what I felt, that you actually come closer to what could be the optimum with this technical advantage.
Timo, is that even before trying out these new vehicles, were you excited by it, or did you have some doubts in the beginning before actually trying them out?
Well, when I started at Porsche back in 1999, so it's a few years ago, as a junior, my first car was a GT3 Cup car, a 996, with H-pattern gearbox, with analog instruments, and there was no button on the steering wheel. At the end of my career, I had I think 30 buttons and switches and rotary switches, hybrid car. The car was fully advanced, and I couldn't relate. It could be the same fun, but that's what I mean. You could be with H-pattern gearbox, with a clutch. We could drive around, and I could have the same fun than with a technical advanced car. It's just different. It's more precise. You have more possibilities. You need to understand it. You need to understand to use these possibilities. Otherwise, it doesn't drive you anywhere. But if you know how to use it, then it's a progress. And I think that's what I'm trying to drive at. That it lifts the performance, which is important in motorsport. And I think every day on the road as well, to be more efficient and to have other advantages.
Carl, did you want to jump in?
Yeah, and maybe just one simple thing: braking.
Yes.
You have the brake pedal, and the experience is great if you have a consistent feeling on the brake speed in normal road driving or in racing. It's super important. And in the background with a modern vehicle, maybe like the fully electric Cayenne, that's behind that wall.
Yes.
Will come to the market next year. You could recuperate up to 600 kilowatts, and you don't feel it when the calipers, the mechanical calipers kick in. You have still access to the full ESP, torque vectoring features and things like that. So in principle, for the driver, it's easy, it feels natural, and more or less all the rest is executed by superior mechatronical systems, but conducted by software.
I see.
So in there, really software meets the road, as the tires are the only contact points that could bring that to the road.
I see. It's very impressive. Roger, let's talk a little bit more broadly about the competitive landscape at the moment. Obviously, at this IAA as well, we have a lot of Chinese players that are on display. And they've made strong advances in software, and especially those with a different background to automotive. There's a lot of the consumer electronics background companies as well. What do you think sets them apart in terms of their capabilities with software that to be honest, some Western players have had to do a catch-up?
It's a very good question. I think you go right back to the beginning, education, the education of young people. If you look at what is emerging through the education system, not just in China, but in Asia in general, there is a stronger focus on STEM subjects. There is, I think, a better awareness, and we can think about some of our challenges and problems and looking for an instant fix. We better do that in, Q4, Q1. But sometimes you have got to think 3 years, 5 years, 10 years. And through things like, I think, a better focus and I say the West, to put it in a general term, on educating children better for the future technologies, because to a certain extent, we seem to have a system designed around educating for, if you like, an industrial landscape. Education in many ways, the core subjects people follow, haven't changed for decades. You could argue 100 years or more. And so I think there needs to be foresight, much better foresight between industry, between companies like Porsche, between governments, between educational institutions, to change that ambition. Because, talk to Dr. Steiner or anyone else involved in running a company that certainly focuses on great innovation and development. You need talent. That talent has to start its learning somewhere. So I think I would advocate and suggest that companies and people like Timo especially, glamorous people like Timo, racing drivers, go into schools, talk to the young people about how, okay, they're not all going to be racing drivers, but they can get involved in the new technologies around software and development, because that's where the Chinese at the moment particularly are so strong. what's coming out of their schools and universities.
Nico, I mean, what's your perspective? Is it unfair to say the Western players are doing catch-up with the, Chinese players? Obviously, Roger pointed to the education as a route, one of the, big causes as well.
Education, but education is really at the top level in China as well as in Europe. What helps is if you do things in a playful manner, just check things out. You are willing to take a risk. You are pushing technologies and try to bring down barriers between departments or between different education things. This is definitely something we need, as more and more innovations are no more innovations where one guy just has one smart idea, but systems, mechatronical systems, software capabilities, cloud capabilities, AI capabilities are really conducted in a good way together, and this brings a lot of new functions, innovations, and this needs also maybe different education, teamwork, willingness to work together, but also fun to just test, try, and check it out.
Curiosity.
Yeah.
Great. Stefan, I'd like to talk a little bit on the safety element. We talked a little bit earlier about, obviously doing it the right way. Software will bring, I think, car safety to a new level if you use the AI and data on the cloud to enable prediction about what's going to happen. But before we go to the prediction phase, we have to roll out these software-defined vehicles safely. And from what we've seen, I guess recently, there's been a lot of bugs or glitches in the initial rollout. How do you make sure that we don't see these technical glitches and make sure that the full potential that software actually has in terms of safety, can be reached?
We just spoke about the competence of software development and that maybe other parts of the world already started education very early. But what we should not forget is no matter which brand you choose, no matter which market, it's always about bringing physics into software. How do we do that with regards also to safety? We're starting on a system level. We are breaking that down into an EE architecture. We are also then breaking that down into a software architecture. We are then developing the software, and now how do we make sure that it's safe to use? Safety security is the highest priority that we do have. So in the end, we are, as I said, we are slicing that into different layers. So we are starting with software models that we test, making sure that they have no failures inside. We then test the source code, making sure that everything is fine and we don't run into any bugs. And then we are going again up into these layers, meaning we are using the whole control unit, testing the control unit, and also in the end, we are then testing the complete vehicle to make sure that all corner cases, different driving situations are working as we expect them to work. And you also spoke about data and AI. So we are talking, of course, also about a lot of different test cases, scenarios, and data which needs to be analyzed. And there also AI, of course, is a very big step forward and a very good lever and help to make sure that safety always is on point and that we are not running into any issues that needs a fix.
I see. So it's done in phases, but when you do reach that prediction, using the data and the prediction phase, you do agree that it will bring safety to a whole new level for vehicles, or?
I mean, the question is always when we talk about safety, are we talking about some kind of safety in a process to make sure everything is fulfilled, no matter if it's requirements, if it's regulations, or if we talk about safety in the meaning of we have different driving situations. So also to the panel that was previously done around autonomous driving, of course we have to make sure that we always stop on point if there's any obstacles coming up. And these are two different areas that of course need two different solutions. So first of all, it's about the software features and that we are making sure that we always deliver the right performance. And on the other side, it's about the development method, development tools, development processes where we include, of course, safety to the highest standards.
Okay, great. Roger, are you convinced about the safety of software-defined vehicles, or do we need backup systems to ensure that they do work properly?
Straight answer, no. Because, no, I just feel that, and I'm not being personal of the Volkswagen Group or anyone else, but when we've all had experience of what software not working in some fashion, when it's at the raggy edge, particularly in performance, if there's not that resilience, if there's not that backup system in some fashion, yeah, I do have a degree of nervousness, if I'm honest. And I hope in saying no, I wasn't being rude, but I do know I think I know how challenging this is. And I mean, it reminds me of an experience I had, well over a decade ago now, 11 years ago or something. I went to Croatia and met Mate Rimac, and we went out in I think it was a Concept 2, I think it was. So it would have been like an early Nevera. And that thing of, power is nothing without control. And when you have these systems now, the dynamics that are available because of electric vehicles, and so many things are happening quickly, and you know how things happen fast when you're driving at 150 miles an hour.
Yes.
It's all coming at you, haven't you? So you rely on software to be so quick and so reliable, to work so well. That power is nothing without control. So yeah, I think this whole thing of seeing software becoming so sophisticated and so advanced and the processing being so fast and precise, it's opening up all of these additional aspects of making driving really connected, really dynamic.
Yes.
I don't mean connected with your phone. I mean, where you really feel connected to the road and the steering wheel. And it's like, you can describe it better than me. You're a racing driver.
Timo, I mean, how do you feel about the safety? I mean, there's data privacy issue as well, but yeah, how do you feel about, do you have any safety concerns with software?
It's a process as well, like if you're going through these phases that you need to build up the trust. But when I speak about motorsport, you have a close team, and you see that more technical innovation comes into play, and then it's building up. I mean, there's a funny short story, like in 2002 we started on the Proving Ground at Weissach the development of the first traction control with the 911 GT3R race car, and I was doing the first outing, and it was not fun at all because it was like a handbrake, so it was not sophisticated, nothing, it was just purely on-off, like a switch, And us drivers back in the day, I mean, we're talking 20 years ago, with disconnecting it because we said, okay, never it's going to be faster, we don't need it, we don't want it, we want to have, slides and stuff. But over the course of, 1 or 2, 3 years, we came to the point where it was faster over the stint, when you have a stint like 1 tank of fuel, 1 hour, and then the tire consumption was lower, significantly lower with the traction control on. So we had different steps that we would lower it, and this is as well, because we argumented in the beginning, you're in the TC, you're about to close the throttle, and then it would let go, and you have a spin and you have a crash. So safety, as a driver point of view. But in the end, over the years, we developed it, we got the trust, and then it was faster, and then it was an eye-opener, and and then there was the next thing that came along. So I think it's a process as well, to build the trust and. Could
I ask Dr. Steiner about when it's code meets the road literally, and I think you've both mentioned tires. What sort of development might we see around, managing tires better? Because the way you drive will impact the performance of how your tires manage. But is there technology coming that is going to help us manage tire wear and tire control better?
For sure, there are, let me say, more modern tires with directly integrated sensor for temperature, pressures, and things like that. Then to manage a tire better could be supported by predictive measures if you know more about the track temperature in racing, or know where there might be wet places the driver could not see in time, but same on road. So we also use tire noise, to tell the system and the driver indirectly more about the grip level he could expect. And if you look at such technologies, you could not expect more from software and connectivity-based technologies, that you could have access that the car with its own sensors, the driver with the sensors doesn't see, doesn't know. So if it comes to prediction by certain patterns, but having access via the cloud to any crowd information or sensors that are not attached to your car but to other cars or infrastructure, you could imagine that you could manage a lot better. So it could be tire wear, it could be friction prediction, it could be thermal management for super fast charging, it could be efficiency, safety, and in this aspect, connected cars and software-defined vehicles could go even beyond what's possible with all the car itself sees and has access to with his sensors and the driver. So this is definitely something where you can really add on compared to what's possible with the most sophisticated, let me say, mechatronic system itself.
Right, I see.
So, and it will be tires for sure, for performance, for safety, but also for driver experience. They are key.
Yeah.
And the more you know, the better. And the better you predict, the better.
Yes, yes. And can I know it's not a topic, but can I just shout out Porsche for what's behind there, I think it is, the wireless charging launch.
That's your favorite.
Well, it really is. I mean, I've been in and around the electric vehicle industry for 20 years. I won't bore you with the whole story. But to see an OEM now actually presenting to the market wireless charging is fantastic news. And it's another dynamic of showing that the electric vehicle opens up a whole swathe of new technologies and things that can work so well. So hats off to you.
Thank you. Yeah, thank you. It's super convenient, and between the charging plate and the vehicle itself, there is no more connection, no power line communication, nothing like that. So this magic all is conducted via software, wireless LAN, and other technologies. So thank you, and I think it's another step to make electric driving even more convenient.
Yes.
No more hassle at home with
cool,
any cable, any card or whatsoever. Just park the car and that's it. Next morning, it's full.
Yes. Can I ask a little bit about, we've been talking about enhancing the driving experience using these various software technologies. What about for a premium experience? I mean, Porsche has a very special brand value and that premium feel to a car. How do you ensure that experience through a software-defined vehicle?
So in principle, let me say, drivers are human beings and they are educated and they have their experience and always look for, at least sporty drivers, for feedback. So they would like to get feedback from the car, what's really happening on the steering wheel, on the brakes, slight vibrations, maybe some noise, predictive behavior, and we love our cars to behave like a track tool, so come as close to the experience a race driver would like. And whenever we can support this, make this better, and let the car behave as natural but as precise as possible in whatever conditions. We think here software technologies in principle are helpful and supportive. And the opposite would be that our cars behave and drive like a computer, like a synthetic product. This is something we do not like. There might be other brands who would like that, but for Porsche, I think the car, it's a driver-oriented car.
Yes.
We say driver experience instead of user experience, as we have drivers, not users. And we look for the best driving experience, most predictable, most telling to you without annoying you. Yeah.
Stefan, we talked about this a little during the morning sessions as well, but CARIAD obviously is doing these software stacks for the various brands as well. As we've been just talking about, Porsche has a special character. Is that a challenge to maintain those various personalities for each of these brands using the various software stacks that you have?
Is it a challenge? It is Yes, it is, but it's a very nice
Of course.
one. I just was thinking about when Michael answered your question, how can we maybe describe it and somehow grab it? Thinking about a few years back, there were no drive modes. There was just one single setting for the vehicle. Nowadays, using maybe not a Porsche as an example, but the Audi A6 e-tron.
Right.
The spread of driving modes between efficiency plus and dynamic is so big and is so huge that every customer can, based on a different situation, based on different moods, influence the driving behavior, the driving style in many different ways. It has an impact on the steering, on the accelerating, on the braking, on the ride comfort, on the ride style, which means in the end it gives us a great opportunity and possibility to increase the spread of character in one vehicle. And of course, we also use that in our software stack to develop it once for many different vehicles and different characters. So one software stack in the Porsche Macan compared to also a comparable software stack inside the Audi A5. Different powertrains, different behaviors, different vehicles, but one software stack. So in the end, it is something where we really can scale to develop that stack once, as I said, and really make use of that in many different ways. So the way how we can influence driving behavior, driving feel, driving experience with software just open up completely new levels.
So,
And is challenged by different brands and
Yes.
for sure different expectations.
It is. That's true,
You
yes.
have to put that in one
Yes.
code.
Yeah.
I'm looking at the online questions, and we have a question for Timo. So let's move on to some of these questions as well. So which control interventions in racing, such as brake, migration, enhance driver confidence without dulling feel, and which would you ban for road cars? Sorry, did you get that? Enhance driver confidence. Which control interventions in racing enhance driver confidence without dulling the feel? Which would you ban for road cars?
Which I would ban in road cars or would bring to road cars?
Yeah, which control interventions, I guess, that you don't like in racing?
Okay. Well, it's the perspective. I mean, obviously there's different rules. So, but to keep it short, like I would just for driving fast in the races, I would ban the ABS. You know, in some of the categories, it's allowed. In some categories, like F1, it's not allowed. But that's something which I would personally, as a racing driver, ban from racing. But obviously on the road, it's something which definitely brings safety, which is absolutely necessary on the road. For different surfaces, or somebody brakes on front, and then actually the ABS helps you not to crash into another car. That's purely safety. But for racing, to make it a bit more spicy, it's something I would ban. Yeah.
Great, thank
but it's
you.
a personal preference. It's like.
Great. Let's see whether we have one more. I don't know if this one's so. I don't know who's the right person for this, but could heavy personalization make cars harder for older drivers or those with limited mobility? How do you keep it inclusive?
Personalization of the car and the behavior. This is something that we will take benefit of, but from my point of view, the customer has always to say to which extent does he like to give the vehicle access to data, personalized data, styles of driving, habits, daily drives, weekends, things like that, and even beyond the car, having access also to your calendar, to any data that you allow to share in the cloud. So there is a lot of room also to make the car more intelligent,
Right.
more adaptive. But from my point of view, we should provide capabilities, functions, but let decide the customer, the driver, whether he likes it or not.
Okay.
I think it's a really good question, because if you think about the marketplace, look at the demographics of the Western world. It's an aging population.
Yes.
And it's always amused me that a lot of OEMs these days talk about looking for the younger market. Well, without being rude, the younger market haven't got the money. the people with the money are the older is the older age group.
That's
so
true.
if you can develop your products to give to, you know, and I'm saying this because I'm an older person, so I know I'm biased, but give it to people where not just some of the things to do with maybe, you know, some of the things that happen when you get older, but just because you're getting older doesn't mean you don't want to drive an exciting way. And in a way, what you want is maybe some software and capability and functionality of the car to allow you to drive a little bit faster, almost compensating the fact that your faculties, you're not quite so quick. You know, I'm never going to beat a racing driver anyway, but if you matched us two, you're bound to be quicker because you're so much younger than me. And if there's software that can compensate for my slight momentary hesitation, you know, I'm not a doddery old driver, by the way, but you know what I mean.
Yes.
And again, going back to reality and marketplace, there's an aging population, they've got shitloads of money, and the business of selling cars with capability to give them something, yeah, that's the way forward.
There is a lot of room for assistance in any direction of using a vehicle, driving a car.
Stefan.
To maybe add to that, we very often talk about how can we make the car more dynamic, what can we else do to also maybe make it more comfortable. What I really like about the question is we're talking about mobility, we're talking about technology. So just thinking about use cases, you can open the car, the ride height is going up, the seat is going back, so you can enter it in a much better way, and also then the road towards autonomous driving is something that I think can be very much helpful with regards to that. And also when we talk about assistance systems, as of today, vehicles can react to different driving situations. If it's icy, if it's rainy, when you approach the curve and the corner too fast, of course we can try to react, but if you overdo it, there's physics and there are laws that can't then just make disappear. But if we think about the future, if we are using the data, if we analyze road surface, friction of the road, and if we then also can provide this information for vehicles that are coming behind or that will drive the same area and situation at a later point in time, then of course we can start to give warning signs to the driver, or also in the future then directly to influence vehicle speed, corner cases, and by that making the car more safe. So I think the question is a really nice one and also describes how software can improve vehicles, not just when it comes to dynamic, but also when it comes to mobility in general.
Yes, that's true. I'm also not a very good driver, so I'm really looking forward to these advances to help me drive as well. So not just for the aging, but for people who are not confident about driving either. I think, let's see. Don't think we. I wanted to ask maybe Roger, since you've had, you've been spending a week at the IAA as well. I know this is a Volkswagen event, but and Porsche obviously today. But did you see any software-defined vehicle that you felt sort of emotionally very excited by, or that you felt that's just the future?
Not that stand out, if I'm really honest. But what I am very pleased about is this is the third IAA mobility I've come to. I think it was a very brave move of the German industry to move from Frankfurt, where it was an unadulterated car show, into a mobility show, to be more comprehensive. And I think, use that word zeitgeist, pick up the sense that, moving around is changing. The dynamics of the population is changing, lots of things changing. So I think this being the third IAA mobility, it feels more confident. I've said it a couple of times on other stages. It feels like the German industry, car industry, has just not quite woken up, but is now showing more products. I think we were talking about this, Dr. Steiner, backstage. Before, it's been about, this ambition, this pilot, we might do this test, this. And people are a bit fed up of that. Because they see the Chinese and others coming out with product all the time. So I wouldn't pick a particular car, but I would talk about the spirit of enterprise and the fact that we're now seeing products, in the market from the German players. What is it? What's the word for strong in German? It's Sturm. Sturm. Is that strong in German? How do you say strong in German?
Stark.
Yeah, stark. It's more stark. That's what I was meaning.
Great.
Thank you.
Is that a fair description, Mikal? More confidence than the European car makers, or?
So I think what was really important is that we do not only talk about technology, but that we bring cars to the customers. Cars that are affordable and cars that show high tech. And what's the beauty is here on this booth and within the Volkswagen Group, we have all of them.
Great. I think that's a great way to wrap up this session, and I think we're just about to run out of time. So thank you so much, and please join me in thanking our wonderful panelists.
Thank you.
Thank you.
Thank you. Thank you.
Thank you.
So much. Thanks for coming today.